Hello. In the previous video, we went over the solution for the calculator exercise, but there were a couple of issues that I mentioned that should be fixed, and I didn't feel really well. So let's fix those issues. The first one, okay, let me first run the application. So we are in the directory, and here if you can just run ls-l, then you can see that there are two files, the application and the test itself. And if I run the proof and the test script, then you can see the tests are passing, so that's fine. Let me run first of all the application to see what's going on. So what I wanted to show you that I didn't know how to show earlier. So this is the location of the page. I can reload it and I can see the output. Now one of the things that we saw that if we divide by 0, okay, or without even the 0, and we click on calculate, then it says cannot divide by 0, which is fine. But as you might remember that this actually says this says cannot divide by 0, so a regular user would just see this human error message. But behind the scenes, the HTTP response, we set it to 400. Okay, so if we go back to the slides here, you might recall that here in this case we send the bad request, which translates, so we set to the status to be bad request and the cannot divide by 0 when we divide and y is 0. And here when we are testing it, we are checking whether it's a 400 bad request. So this is not a 200 okay HTTP request. But how can you in the browser see this? Okay, and I tried it to click on the view page info and it wasn't there. So as it turns out, I read about it. If you go to the web developer, this is in Firefox, in other browsers it's probably different, and you open the network tab, then let me enlarge here. So this is where we're going to see the network requests. The same would be if you press an F12 and then you go to the network tab here. So if I go back now and click on calculate again, you can see now what were the requests that went to the server. And here you can actually see that this was the post request, and you can see that it got a 400 bad request status. There's also the favicon, that's just the Firefox trying to download an icon. That doesn't matter for us now. You probably should create an icon. That's what usually comes here, this icon. And it gets 404 because it's not found on our server. But that's not what's interesting to us. What's interesting to us, let me even, not that window, enlarge this further. So you can see that that's how you can see the status code. Okay, but that's not really so that's only one of the things I wanted to show. The other thing is that you might remember that, so first of all, yes, here, why did even the application assume that's a 0 if I didn't provide anything? And what happens if I just type in hello? It will still assume it's being at 0. And now this is an error message, but what if I do plus? Okay, so 3 plus hello, and it says it's 3. Okay, and yeah, I get the warning messages here because that's how it's implemented, but that's probably not the right way to handle such cases. Probably you would like to give some error message to the user. So we can go and fix the application, but I think it's much better to first write the tests. So that's the same, the TDD idea basically. So I'm going to open the test file. And what we're going to do is that first we're going to write a couple of these test cases, a couple of more test cases, in which the response is invalid input. Okay, so I copy 2 lines here and create a new set of cases, bad cases, I call them. And here I say that what happens if X is hello. Okay, then I would like to, and the rest are okay. Then I would like to get back invalid input. So you could in your application, you could actually detail what is the invalid input. The X is a string, or I haven't received X, or something like this. But at this point, I don't want to go that far. Okay, so I just created this example. What happens if the user gets the string hello and the invalid input? And then I'll copy these 4 lines, basically, or 5 lines. Okay, I copy them. And in this case, I'm going to go over the bad cases. So these are the bad cases. I'm going to send them in to the calculator. Here I'm going to expect 400 bad requests. So I'm going to expect this string instead of 200. Okay, I'm copying this one. And I'm expecting not this message, the test result is, but just the text there, what we said there. So it's invalid input. Actually, we could, if you wanted to later create a mapping, a better error messages, then you could put in the test cases, each one the exact test error message that you're expecting from that kind of an error. Okay, so now if this is already checking it. Now, if we run this, this is supposed to fail because the behavior is not that yet. So if I run this now, so what I do here, I'm quite used to this, I press Ctrl Z to put the editor in the background, and now I have the terminal. You could as well open a separate terminal and run the tests in a separate terminal, especially if you're using some other editor than VI, then you probably do that. So now I can run prove and test here, and it fails. It fails because we got 200 OK instead of 400 bad requests, and we got the result is 2 instead of the invalid input. Of course, because we haven't implemented the error checking yet. Okay. One thing that might bother you is that it says its status. It doesn't say exactly what case. So, and it here also content. It didn't say which case it happened. It says in which line it happened, but because we have a loop, this is going to be several of these cases are going to be. So it's on line 40 now this time. Okay, so line 40. Let's jump to line 40. This is where the status could fail. Now, in order to have a better understanding what is the test case, we can put here, actually we can replace the single quotes with double quotes, and then we can interpolate into here the actual test case, so the input. And for that you can write something like this. So we can say x equal to the dollar case, arrow and the square bracket and curly braces and x. So that's going to be x. It will display the content of x that we are sending in. The same I can do, I copied the same to twice. Okay, so I make it a little bit more spacey, and I can put it here y as well. Okay, and the operator. So this is going to show now what is the exact case, and here the same with the content I could do. So in this case I put it also around in the content, and I copy paste this whole part. I hope that I wrote it correctly before I copy paste. Now I probably am going to get better error messages. So in the tests, so I run prove, and now in the prove, we get the fail test. This is the test. Okay, so I get the actually details of the test case. It's going to be much easier for me to understand what is exactly the problem. And then I could take the whole idea and copy it in all the other cases where we had. So here this is the status. Okay, this is one place, and I can copy the other one as well. Okay, I can copy it to the other place here as well. And you can do with the same as the content. Okay, and let me run it again just now. So yeah, sorry, that wasn't a good idea. So this is not cases. There are no cases here. So we can just restore here the status, because there's no point here. There are no cases. So only the first two we have cases. So we can run it, and the test fails in the same way as it did just before. Okay, so this is actually a refactoring of the tests. I should have done it separately before I started to write the test. That would be like the correct, the proper way for doing this, but sorry for that. So now that we have a failing test, we have to fix the code. So I'm going to open the application just in another tab, and here this is what we need to handle. So we have to remove the defaulting to 0, and then we need to check whether this value is actually something that can be converted into a number, not a string, not empty, nothing. So we can use the module which is called scalar util. Use has a function scalar util, if I remember correctly. I always forget if this is utils or util. It looks like number. So there is this function that can check whether a string can be converted to a number. That's basically that this checks. And it's sort of Perlish way saying, okay, I'm going to commit myself that's going to be really a number. It just looks like a number. So here we say that if $x looks like a number, if it can be converted, then we can go on. But if it's not, okay, if it's not look like a number, then we have to give the result in the error message. So this is the error message. I need the 2 lines here in the middle. Okay, I set the batch status, and instead of cannot divide by 0, I send back incorrect input. I think that's what we are expecting, right? So let me try to run this and see if I managed to write it correctly. And well, it almost, in one case I was expecting invalid input, and then now I type in incorrect input. So we can say incorrect input, invalid input. So let's fix that. Invalid input. Okay, I didn't say what, so now we run it. Okay, and so we have another case here that fails. Okay, so case on 946. That's surprising a little bit, but let's see why. 46. Not here in the test file. 46. So this test case fails because when I wrote it, I didn't give x any value, and even though what I was actually checking is the case when y is 0, and now because we are checking the validity of x, we don't get to the point to report the problem with division by 0. So I'll have to update this test case because the test wasn't really good. I think I mentioned it back in the previous video as well. So in x we're going to give a real number, okay, or a string that looks like a number, and I can run the test again, and now the tests are passing. So in this case, and that's actually a nice example to show that just because we have tests doesn't mean that the tests are correct. Okay, so that test might be also faulty or slightly faulty or not covering exactly the case that we wanted, and we have to fix then the test. So now you can see that the tests are passing. Let me show it again. So this is how we run the tests, and all the tests are passing. So we know that in case of incorrect input, for x we get this invalid input report. I can add a couple of more test cases. So what happens if the string is empty? That should be the same. And what happens if there is no x at all, if we don't provide it at all? So all these cases should get the same response. So let me run the tests. And besides there is this warning, okay, everything is fine. So the warnings actually, I think they are actually coming up on the tests when we are printing out the test case. So that's coming out from this line, probably here, where we are printing out the value of x. So maybe that we don't need that one. Okay, maybe we can turn off the warning. So let me do something initialized. I don't remember. Okay, so there is a way in use warnings to turn off specifically that kind of warning, and then you can say, I mean, I can say here in this line, I can say no warnings. Okay, and then I think that will fix this. Okay, so we don't have this warning, and we should be probably more specific. I don't need it's undef. I don't remember. Okay, let me try to look it up. Okay, it doesn't like that one. So Perl turn off warnings of undefined. Maybe it helps. Okay, if I maybe the Perl monks have something. Okay, initialized. Here you have, okay, it's super small as usual. So this is what I need to do. I copied this one. Okay, no warnings initialized. In this way, let me try it just to make sure that it works. Yes. So in this way, we turned off this specific warning in our code. Okay, and in this block only. So if the application generates the warning, then it will probably still print it out. Okay, but not if our code does. Okay, so that's gonna be nicer. And then we can also go ahead. So this is basically how we fixed how we implemented it for X. We can now do the same for Y. So we can create some bad cases. Okay, I can copy paste here this one, and I say that the X is now get some number and the Y is the text. Okay, and I can do these copies again and have here an empty string and have here no Y at all, and error messages should be the same. Well, it should fail now. Okay, right now the test should fail because we haven't implemented the checking yet. So now we go to the application, and in the application we say, first of all, we have to remember that we had this default, that we don't need the default anymore. And here the not looks like a number. We also have or, and then say not looks like number. Yes. And adding the $y. Yeah, and I didn't even celebrate the fact that I managed to write correctly the name of the module, scalar util, because there are sometimes I always mix it up if it's plural or singular. Okay, so now I can run the tests again, and all the tests are passing this time. And the last one, the last case that I wanted to check is what happens if the user provides two numbers as, let me copy another one, okay? Let me copy a good one, okay, from here, okay? So provides two numbers correctly, but provides an operator which is else, something else, okay? And then it should be also invalid input, okay? And there too, I could also give other cases, but let me just try this one first, okay? So now I run the proof, and it fails, okay, because we don't check whether the operator is correct. We just assume apparently some operator, or we don't do anything actually. I think in the code what happens is that if none of that operators match, then we just return the result which is undef. Okay, so here we also have to check whether the operator is one of the values. Okay, so we can also check here or, and then I'll have to do it some way. So we can create here a list of operators. Okay, we can let's say my ops, and then create a list of the other operators with add and deduct and I don't know if it's written correctly, and multiply and div. Okay, so these are the correct values, and I can actually turn that into a lookup table. So I create an ops hash and I map it to be the key each one of the values, and the value is just anything. Okay, so this way I created a hash where the key is the word add or deduct or multiply or div, and the value is just one. And then I can check if the operator, which is $op, is in this hash. So we have the ops, or maybe it should be valid ops. Okay, so let's call it valid ops, and we can even better probably exists. Okay, so if not exists, so now we check whether x is if it's not a number, or if y is not a number, or the operator is not in the valid operators. Okay, in all those cases we return invalid input. And now if we run the tests, then it passes. Okay, so we know that this is supposed to work, and we can add now a couple of more test cases here. For example, if the user somehow provides nothing, or it's not even provided, all these cases, then we run this tests, and then we get back the results, and they're here. Here too we have a warning, okay, that we don't like, so we could actually add the no warnings there too, in that case where we had no warnings here, and there's some other case where we can use the no warnings as well. So where is it coming from actually? It's coming from the application line 29. Okay, so let me check that one. Line 29 in the application. Okay, it's because we are using here, so maybe for ops we actually need to give a default empty string. Okay, so we'll be able to use it. Okay, because what happens that we are using, I mean, okay, no, let's not give any defaults here, so just say if or not defined op. Okay, or not exists. So now we have a slightly complex thing here. Maybe we'll need to split it up to make it easier to read this line. But basically we say if not defined op, then we already short circuit this condition and get to this invalid input result. So let me try to run this. And now we get the whole thing without any warning. So that's nice. And I think that's it basically. What we would like to do now is that, one thing, okay, before we do it. You might want to know, so when you run these tests, we said that, okay, what happens, so we have these cases where the operator is something else, and you might wonder how could that happen. And let me look at now the application, plug up, that's it, not plug up. Okay, so now we're running the application, going to the browser and running the calculator. So if you go back to the main page of the calculator, you might be wondering how could the user provide something else than here. So it's not that way. You can use curl or some other programmatic way to access this web page and send in the information. So it's not just the users that you are concerned with, that they are accessing the website in a regular way via their browser, but also the other people who might want to write a script, a program, or some other way to access your website and send in, then they can send in any arbitrary information. So it's better to check your input. So now what we just wanted to say is that what happens if the 3 plus hello, and then if we get the invalid input, or if we get something here I type and here I write a number, then it's again calculate and we get invalid input. So it seems that this works. Oh, and then you might also want to see that this still works. Okay, so the application still works if you don't trust the tests. But and well, definitely you should look at you should do some manual checking as well once in a while at least, to make sure that the code returns exactly what you wanted, and then the page looks like as you wanted, and so on. So I think that's it. We spent a lot more time on this exercise than are originally planned, but I think on the other hand that we got some things covered that I haven't planned earlier, but they are quite useful, I think, for programming. So I hope you enjoyed this, and then let's go on for the next part in the next video.